Hello and welcome back to the Learning Palette. Today we're going to explore one of the fundamentals of science, measurements and units. Whether you're here in middle school, high school, or preparing for IGCSE, mastering this topic will make your science journey way smoother. So let's get started. What is measurement? Measurement is the process of comparing an unknown quantity with a standard unit. For example, if you say a table is 1.2 meters long, the number 1.2 is your measurement and meters is the unit. Measurement is something we use daily, like checking height, cooking recipes, or timing events. Physical quantities are measurable properties of things around us. Some common examples are length, mass, time, temperature, electric current, light intensity, and amount of substance. For length, we use meters. Mass is measured in kilograms, time in seconds, temperature in Kelvin, electric current in amperes, light intensity in candelas, and amount of substance in moles. These units are part of the International System of Units, or SI, which is used worldwide to keep things consistent. Units come in two categories, fundamental and derived. Fundamental units are the basic building blocks that can't be broken down. These include the meter for length, kilogram for mass, second for time, Kelvin for temperature, ampere for electric current, candela for light intensity, and mole for the amount of substance. Derived units are combinations of these base units. For instance, area is measured in square meters because its length multiplied by breadth. Volume is in cubic meters since its length cubed. Speed is measured in meters per second, which is distance divided by time. Force combines mass and acceleration, and it's measured in newtons. Pressure is force divided by area and measured in pascals, and density is mass divided by volume, measured in kilograms per cubic meter. Before the SI system became the global standard, different regions used various systems. The CGS system used centimeters, grams, and seconds. The MKS system used meters, kilograms, and seconds. The FPS system, common in some countries, used feet, pounds, and seconds. Today, the SI system is widely adopted around the world for uniformity and clarity in scientific communication. Different physical quantities require specific instruments to measure accurately. Length can be measured using a ruler, a vernier caliper, or a micrometer screw gauge. Mass is measured with a beam balance or a digital scale. Time is tracked using a stopwatch or clock. Temperature is recorded with a thermometer, and electric current is measured by an ammeter. Accuracy, precision, and errors. Accuracy is how close your measurement is to the true value. Precision is how repeatable or consistent your results are. Errors can mess things up. Systematic errors come from faulty instruments or methods. Random errors are unpredictable and vary slightly. Parallax errors happen if you read a scale from the wrong angle. Significant figures. Significant figures indicate the precision of a measurement. For example, the number 3.50 has three significant figures, showing a higher level of precision than 3.5, which has two. Zeros between digits count as significant figures, but zeros at the beginning of a number do not. Zeros after the decimal point are significant because they show precision. Optical phenomena and illusions. Sometimes what you see doesn't exactly match reality due to the behavior of light. For example, refraction occurs when light bends as it passes through different media like water or glass. That's why a pencil placed in water appears bent even though it's straight. Mirages occur on hot roads where the air's temperature gradient bends light, creating illusion of water. Optical illusions trick our brain into misinterpreting shapes, sizes, or colors. For instance, Circles of same size may appear different depending on the surrounding shapes. These phenomena remind us to be cautious when relying solely on visual measurements. Before we wrap up, a huge shout out to Khan Academy for helping me understand this topic better. Their visuals and simple explanations really helped me reinforce these concepts. To sum up, measurement compares quantities in standard units. There are 7 base SI units. Derived units combine these for things like force and speed. Accuracy equals closeness to truth, precision equals to consistency. Significant figures show precision in numbers. Convert everything to SI units. And don't always trust your eyes. Optical illusions are real. Thank you for watching. Don't forget to like, subscribe, and share if this helped. See you next time for more Science Made Simple.